Today I am going to solve one steady state mass balance problem. Here is the problem statement. 3 reactors linked by pipes. So here 3 reactors, reactor 1, reactor 2 and reactor 3. The rate of mass transfer through each pipe is equal to the product of flow Q, that is meter cube per second, and concentration C, milligram per meter cube of the reactor from which the flow originates. So here Q into C. So that is, if you put the unit, so that is mg per second. And question is here, if the system is at a steady state, solve for reactor concentration. So for that reactor 1 concentration is C1, reactor 2 concentration is C2 and reactor 3 concentration of C3. Now we have to find out C1, C2 and C3. Other parameters are given. So after doing mass balance, we can solve that C1, C2 and C3. Now first I have to write general mass balance equation. So here general mass balance equation is rate of accumulation is equal to input rate minus output rate plus generation rate minus consumption rate. Now at it is saying that steady state, so rate of accumulation will be 0. Generation rate and consumption rate is also 0 because there is no chemical reaction. Generation is also 0, consumption is also 0. So here input rate is equal to output rate. Based on this equation, we will do mass balance for reactor 1. So reactor 1 input is here, this is both input, so 200 mg per second plus Q21 into C2, and these are the output. So output is Q13 plus Q12 into C1. Now as we know that input rate is equal to output rate, so we can plug 200 plus Q21 C2 is equal to Q13 plus Q12 C1. So now here the parameters are given, so we can write 200 plus Q21 is given here, so that is 30 C2, that is equal to Q13 is given, that is 40, and Q12 is also given, that is 90 into C1, so that is 130 C1. So 200 plus 30 C2 is 130 C1. So that is equation number 1. So now for the reactor 2 balance, so input is equal to input rate is equal to output rate. So if I do the reactor balance, so this is the 2, so input is here 1 input, so that is Q12 C1, and 2 output, one output is here, another output is here, so Q23 plus Q21 into C2. So Q12, that parameter is given, so 30 C1 is equal to Q23 is 60 plus Q21 is again 30 C2, so that is Q12 is 90, not 30, 90, this is 90, so 90 C2, so C1 is equal to C2, so that is the equation 2. Now if I do reactor balance 3, so here that this is one input, this is one input, and this is one input, so Q13 plus N3 into C1 plus Q23 into C2 plus 500 mg per second, that is equal to that output Q33 into C3. So Q13 is 40 C1 plus Q23 is 60 C2 plus 500 is equal to Q33, so 120 into C3. So now we have 3 equation and 3 unknown. So from that we can easily solve C1, C2 and C3. So now here the reactor 1, this is the equation, reactor 2 equation is this, reactor 3's equation is this. Now if I plug this value, so first equation will get 200 plus 3 C2 is equal to 130 C1, and second equation 90 C1 is equal to 90 C2. Already we did in that previous slides. And third one 40 C1 plus 60 C2 plus 500, that is equal to 120 C3. So we got this equation. So now if I write in matrix form of this, so that will be here. So this is the three equation. So if I write in matrix form, so 130 minus 30, 0 C1 and 200, 90 minus 90, 0 C2, 0, 40 60 minus 120 C3 and minus 500. So this is the coefficient of C1, C2 and C3, and this is the constant coefficient. So we can write this is nothing but A, and this is X and B. Now we can easily solve X is equal to INV inverse of A into B, or if I use numerical technique like Gauss Seidel method, we can solve that. So now here the I'm solving using Gauss Seidel method. So this is the first equation, this is the second equation, and this is the third equation. So equation, rewrite the equation, three equation. So from this equation we can write C1 K plus 1. So K is nothing, number of iteration. So then 200 plus 30 C2 K by 130. From this equation we can write equation second C2 K plus 1 is 90 C1 by 90. Basically C1 K plus 1 and K3. So here, so C3 K plus 1 is equal to 40 C1 K plus 1 plus 60 C2 K plus 1 plus 500 120. Okay, now Gauss Seidel method, initially we have to take at iteration 0 C1 is equal to C2 is equal to C3 is equal to 0. Now we plug this value here. First we plug that C1 value, sorry C2 value, we will get C1, and we know C1 is equal to C2, so same value. Now updated value we can put into C3. So if we put updated value, so C3 will be 5.4487. So similarly, so next iteration, so we got that C1 and C2 1.5385. So we plug here C2, C1 will get 1.8935. Similarly C2 will get 1.8935. If I put updated value in that C3 equation, so we'll get that C3 is 5.7446. Similarly, if I do this iteration, third iteration, again I am putting that C2 value is 1.8935, we'll get that 1.9754, and C2 is equal to C1, so again 1.9754, and C3 if I plug updated C1 and C2, and after doing the calculation I will get 5.8129. Now similarly if I do that, and here if I do 8th iteration, I'll see that that C1 is 2 and C2 is 2 and C3 is 5.833. So now, so after iteration 8, the solution converge. And you can see if you take that relative error, so that will be 0. Okay, so now final solution will be C1 is 2, C2 is 2 and C3 will be 5.833. I also did the MATLAB calculation X is equal to INV into B, so I will also got similar result. So here this is C1, this is C2 and this is C3. So these are the solution. So that's it. Thank you.